So, ladies and gentlemen, we move to our next keynote for this morning. And next keynote is coming from Miss Ritu Favre, who's Executive Vice President and General Manager of Semiconductor and Electronics Business, besides Aerospace, Defense and Government and Transportation Business Unit at National Instruments, better known as NI. At NI, Ritu is responsible for driving growth and defining the system, software, and services capability required to meet the unique needs of customers in these markets. She's also focused on tracking emerging innovations such as 5G, artificial intelligence, and IoT to ensure her teams continue to stay ahead of developing technologies and support customer needs however possible. With more than 30 years of experience in technology industry, including multiple semiconductor industries, Ritu brings a diverse outside-in perspective to NI. She's a seasoned high-tech industry leader. She served as Chief Executive Officer at Next Biometrics and on the Cohu Board of Directors. She also held senior management positions with market heavyweights like Motorola, Freescale Semiconductor, and Synaptics. Ritu currently sits on the board of director of Walmart Industries when she's not traveling as a self-proclaimed expert luggage packer. That's interesting, Ritu. She's inspiring and inspired by the next generation of female leaders in the semiconductor industry as a member of Global Semiconductor Association's Women's Leadership Council. She's also an advisory board member to uh, Microfacturing Institute's 5013 charitable organization delivering high-tech educational program that increases diversity and broad participation in industry employment. With that introduction to Ritu, I would like to invite Ritu to actually get started with her keynote address. Over to Ritu.
Hello, everyone. Thank you so much for inviting me to this year's IESA's Vision Summit. My name is Ritu Favre, and I'm the Executive Vice President and General Manager of NI's Semiconductor and Electronics, Transportation, and Aerospace, Defense, and Government business units at NI. I'm so excited to be here, in part because of my connection to the Indian semiconductor community over my 30-year career. I worked at Motorola for 25 years, and I was involved in the development of multiple design and validation centers in Bangalore and Noida. Later in my career as a senior vice president at Synaptics, I had the opportunity to lead a large software development team in India as well. And as CEO of Next Biometrics, we certified our fingerprint reader products to the Aadhaar standard and had a team of engineers in India that helped to deploy them throughout India. I truly believe that India plays an important role in shaping the future of the semiconductor industry, and I'm so honored to speak about that role today. I believe that India has a once-in-a-generation opportunity to forever shape the semiconductor industry. Today, there is a confluence of multiple factors that is driving semiconductor investment in India. First, it has long been recognized that India has a highly skilled engineering workforce. This is especially true when it comes to IP creation and software development. These skills are increasingly integral to the semiconductor development process and are especially important in semiconductor testing. Second, India's geopolitical context creates favorable conditions for business. From a legal environment that favors IP security to a workforce of engineers with exceptional English language skills, Indian centers are increasingly positioned to be leaders within their organizations. As a result, many multinational semiconductor players have continued to expand their engineering footprint in India. Texas Instruments, for example, was one of the first multinational semiconductor organizations to establish R&D facilities in India over 35 years ago. Today, companies including Broadcom, Intel, Samsung, and NXP have reported major investments in Indian design centers. In fact, India now houses one of Qualcomm's largest IP design centers, specializing in wireless modem, multimedia software, DSP, embedded, and much more. You might not realize this, but NI first opened an R&D center in Bangalore back in 2004 and now employs more than 200 R&D engineers in India. It should come as no surprise that within the last 5 years, India has seen a 29% CAGR increase in the size of its semiconductor design market. During this time frame, we have also seen a shift in the scope of these teams as well. Although many semiconductor organizations started doing purely software development in India, many of these sites are now responsible for first silicon validation and product characterization as well. The growth in the Indian semiconductor community is tightly linked with many of the macro trends that are shaping this industry. Not only does each new technology create business opportunities for companies to take share in new markets, but it also changes the way that engineers design and test these products. From 5G to mobility to digital transformation, these inflections ultimately drive faster development timelines and increasingly motivate a software-centric approach to product design. In my 30-plus years in the industry, time to market has always been a major concern for every project. However, there is no question that with the pace of technical innovation accelerating, the rate of engineering is happening more quickly than ever, and engineers are forced to accelerate every phase of product development. We see this consistently in our industry, from the cost of being late to market to the race to be first. One of the most prominent examples is the race to smaller process technology. Recently, both Samsung and TSMC began volume production of 5-nanometer chips. Today, foundries are vying to leapfrog one another with 3-nanometer and even 2-nanometer process technology. Recently, IBM announced that it had produced the world's first 2-nanometer node chips, promising energy savings of up to 75% versus today's technology. 6G is another great example of both accelerating product timelines and new technical requirements. The idea that engineers are already working on 6G might sound crazy to you, especially as we're in the early phases of 5G deployment. However, each generation of wireless technology can take more than a decade to create. Today, researchers are already working to define what is next after 5G, or what is referred to as beyond 5G. It probably won't surprise you that companies are looking to accelerate 6G with promise of first deployment by 2028. Obviously, in each of these spaces, the early players will have a unique competitive advantage, driving the need to be first to market. With an increasing need to be first, streamlining the engineering workflow has become more important than ever. Inefficiencies in design and test can have a significant impact on release dates. In parallel with the intense pressure to be first, engineering teams must also cope with the fact that each new design is more complex than the one before it. For example, in keeping with the wireless theme, consider the progression and complexity of a relatively simple RF front-end module. When characterizing a 4G RF front-end module 10 years ago, one might have to deal with less than 100 test cases, each with a different combination of radio band, carrier bandwidth, and waveform type. Moving to a 5G front-end module, the number of test cases increases by almost 10x. However, the product schedule does not allow for a 10x increase in validation or characterization time. If anything, the expectation is even faster development. As a result, engineering teams are constantly pressured to develop faster and more efficient test methodologies. In addition to the need to do more measurements, the measurements themselves are becoming more complex. For 5G millimeter wave devices, the adoption of antenna-in-package technology means that there is no longer a physical connection to access the millimeter wave signal. As a result, many 5G millimeter wave devices require over-the-air testing, which is a completely new test methodology. Another example is modern optoelectronics products. VCSELs, or vertical cavity surface-emitting lasers, are increasingly used for 3D sensing applications. With these devices, the desire to limit heat dissipation and power consumption at higher peak powers is driving the need to operate VCSELs for extremely short bursts of time. Pulsing is an important innovation driving adoption on power-conscious applications, such as facial recognition on smartphones. Finally, the acceleration of the MEMS market is sourcing a myriad of test and measurement innovations. Some of the most interesting MEMS measurements are for inertial sensing devices. Testing these devices requires physical movement of the device under test in parallel with measurement of electrical signals, which often requires changes in the approach of most test labs. In many ways, the design, validation, and test engineers that we work with are often caught in the middle of the competing priorities of their organization. These teams must balance cost and complexity with faster time to revenue expectations. In fact, engineers are being tasked with developing more complex devices in less time and at lower cost than ever before. Since doubling or tripling test capacity is often not a viable choice, engineers are forced to be more efficient with the resources they have. From my experience in running several semiconductor businesses, the scarcity of capital equipment budget is magnified at offshore locations. In many cases, the further a lab is from corporate, the fewer resources that they tend to get. This reality elevates the importance of automation software in the lab. These tools are some of the most effective techniques to stretch test equipment budgets as far as possible. I believe one reality is both a challenge and an opportunity is the disjointed nature of many large organizations. Natural silos between various R&D teams and sites often create a duplication of effort. This is especially true in large semiconductor companies. The engineers I talk to in the characterization lab often tell me about new designs getting thrown over the wall with very little collaboration on test requirements and methodologies from the teams upstream. This issue is compounded by the fact that many semiconductor organizations have grown through mergers and acquisitions. This creates duplicate organizational structures, often with multiple teams solving the same challenges. However, not sharing best practices or communicating with one another creates inefficiencies and represents a significant missed opportunity. Obviously, some duplication is always going to happen, but I see many companies benefiting from increasingly sharing both test software and test methodologies across sites. In fact, some of the most successful organizations that we work with have driven efficiency by standardizing test measurement software globally. In our interactions with engineering labs across the world, we have seen that companies who adopt a common software framework ultimately reduce their engineering costs and accelerate design schedules. When you take a detailed look at the workflow of a product characterization lab, simply pulling instruments out of a closet and manually configuring them by hand is a way to characterize a semiconductor device. Instead, over and over, we observe that organizations that first automate measurements and then standardize and test automation software in the lab are significantly more efficient. Standardized software enables quicker device characterization and often results in an ability to expand measurement coverage. And this is true regardless of which software engineering teams adopt. Many of our customers have done this successfully using a wide range of languages, from Python and C+ to LabVIEW. Within the next decade, data analytics software will also play an increasing role in our product development workflows. Today, we already observe the challenges associated with correlating simulation results from the design process to the measurement results in the characterization lab. Effective use of data management and analytics tools is also an important aspect of modernizing the lab. Sharing data across sites and teams is an important step to improving overall organizational efficiency. I know that the idea of modernizing your lab may feel overwhelming. In addition to the new skill sets and techniques, any change introduces inherent risk. Moving to a modernized lab approach often happens in small steps, depending on the risk tolerance and technical capabilities of the organization. One of the things that I want to leave you with is that even small changes, like deciding to automate measurements, can have a big impact. Automation drives faster device characterization and produces invaluable measurement data. Our customers often tell us that they can characterize first silicon devices coming back from the fab anywhere from 5x to 10x faster, simply by transitioning from manual to automated measurements. We have also found that once customers start automating measurements, they tend to also increase the number of measurements. As a result, they end up with more data to help them better understand the behavior of their devices. To give you an example of the scale of benefit we typically see when adopting modern approaches to characterization, I wanted to share some of the results from an example of a major semiconductor company. We conducted an in-depth study of a top-tier semiconductor customer to help them understand the true impact of investing in both hardware and software standardization. We found that our customer saw a 40% reduction in hardware cost. They also saw a 2x improvement in test coverage with same or less time. All this started through effectively automating measurements in their lab. We have talked about automation often being the first step our customers take to modernize their labs. In many instances, the second step is the adoption of a standardized software framework. As I've mentioned before, software can improve productivity, but to do so, it must scale. Even relatively simple devices like ADCs or LDOs require some degree of instrument synchronization. This means that performing simple measurements requires at least basic test automation software. Although someone always must initially write software, sharing code across teams and site can reduce the duplication of effort. This helps other teams get a jump start on product characterization. One of the things best-in-class organizations do effectively is to centralize the development, maintenance, and distribution of automated test software. At NI, our goal is for engineers to leverage off-the-shelf software to make this process easier. We're innovating on a workflow that leverages common IP and measurement software in both interactive and automated measurement environments. Our goal is to enable engineers to quickly bring up a device using device-specific and configuration-based measurement panels. Once the measurement has been configured, you simply save the settings to a configuration file. Later, when doing automated characterization, you simply point to the same config file in the automated measurement environment. All of this without having to do a single bit of programming. This framework helps engineers maximize measurement IP reuse and reduce setup time. Our vision is to continue making it easier for customers to standardize on measurement software. What's more, standardized software also enables consistency in data capturing. This consistency helps lay the foundation for smarter data analytics. By now, you have heard me make several references about how data analytics is the next frontier for test. Each step is the product development process, generates mountains of data, and is often too difficult to make use of it all. I see a sizable opportunity to create deeper product insights by connecting data gathered during different phases of the workflow. While a common software framework can help source consistent data, product analytics solutions can generate actionable insights. Consistent with the need to accelerate product development, data management and analytics tools provide a unique opportunity to improve productivity. Today, each stage of design produces immense amounts of data. That data is often poorly managed and insufficiently leveraged throughout the design process. If you have ever tried comparing simulation with measurement results for a device, you likely know firsthand that it can be extremely difficult to know whether the two data sets were generated using the same settings. In addition, this challenge becomes even more difficult when generating hundreds or thousands of data sets from a single product in the characterization lab. As product complexity escalates with each generation, data management and analytics tools will become an increasingly critical aspect of the semiconductor design workflow. Fortunately, we are seeing rapid innovation in analytics technologies like artificial intelligence and machine learning. As a result, I believe that engineers will heavily rely on these tools to accelerate product development. From automating measurements in the lab to performing advanced analytics across the organization, semiconductor companies are increasingly reliant on software engineering talent to achieve product development goals. That is exactly why I'm so excited to be here today and why I believe that India is extremely well positioned to become a leading location for semiconductor product development. India's unique talent pool with deep competencies in software development are a key asset in our industry. As I mentioned earlier, best-in-class semiconductor organizations are consistently standardizing their software in the lab. With the talent here in India, I believe that the hub of these standardization efforts can be in India. Going forward, I fully expect Indian engineering teams to become global leaders in their organization, directing the strategy for how to best design and test new products. For those of you who work in a lab environment, I would like to encourage you to start thinking about what modernizing the lab could mean for your team. We know that any change comes with inherent risk, but we also know there can be a massive payoff. We are committed to helping you through a combination of products, services, and people. Thank you so much for having me here today. I encourage you to continue to engineer ambitiously and continue being a leader in your organization.
Thank you, Ritu. That was a fantastic keynote and nice to see you.
Nice to see you too, Vivek.
After that talk, same here. So there are a couple of questions, Ritu, from audience that I wanted you to address, though I know you are dialing in from US and it's already pretty late for you. So the first question comes about your topic of modernizing the labs, So the question is that modernizing and remote labs both have become important topics due to, COVID in last 2 years. And India has seen emergence of a lot of startups in technologies area. So how can these startup leverage modernizing, especially remotely modernizing the lab and utilizing those labs, and how can they collaborate with NI in India?
Yeah, I think Vivek, that's a really, really good question. We're finding a lot of new startups coming up, definitely in India. And so as I was discussing in some of my comments, I think really being able to put some of these software frameworks in as you're working kind of around the world with maybe the headquarters, you're able to put these same kinds of frameworks and a common framework throughout all of these startup kinds of labs with the instrumentation that we can provide. NI in India is definitely available from a support and services perspective to help a lot of these companies be able to put these frameworks in and really help to accelerate time to measurement. I think that's one of the things we talked about is how can you get to measurements faster? And I think working with the team in NI India, I think is a really good way to do that.
Thank you, Ritu. Another question from audience here is that you mentioned about disjointed design and test stages creating inefficiencies, right?
Yes.
Now, last 2 years, pretty much around the world, people have either done remote labs or they've struggled already with this efficiency because of work from home or remote work. So, in this period of pandemic of last 2 years, is there anything specific that NI has figured out to reduce these inefficiencies?
I would say, well, COVID has definitely accelerated a lot of this work of really understanding how to work through these disjointed stages. And so, I mean, kind of similar to some of our history together, the different stages that we see are design simulation, going into validation characterization, and into production test. This whole piece of COVID and having teams located around the world and having to work together, I think has actually helped to accelerate breaking some of these barriers down. It's forced people to have to work across these silos. And a lot of this piece that we talk about, being able to share data, being able to share these common frameworks between some of these different stages, I think is really helping customers accelerate their own time to revenue, being able to characterize these chips faster, and then being able to use a lot of the same kind of core test framework, test code between the validation stages and into production. So I think COVID has really accelerated the ability for teams to work together across different regions and across different kinds of silos.
Thank you, Ritu. I'll take one more question in interest of time. So the last question is about 5G. So the question says 5G and sensors at the edge are creating interesting new IoT devices, which is also causing new technologies like embedded antennas. Does NI have any test solutions for over-the-air antennas or the embedded antennas?
Yeah, we actually have a lot of solutions. We're pretty heavily involved with testing in the 5G area. And what's interesting about 5G is there's, as I think everybody on the call knows, there's a lot of bands that are in 5G. It probably has more frequency bands than any prior band of cellular. And so you look at the sub-6 area, we have really, really solid solutions there. We also have millimeter wave solutions and antenna and package solutions. As I was talking about in the speech, we do have over-the-air solutions today. We have kind of chambers that we can provide for both validation side as well as in production tests. So again, NI has a pretty large facility in India, and we would really, really be happy to work with different customers on over-the-air solutions in millimeter wave. We're even starting to do some early work in 6G, as I was talking about in the speech. And so we're very active in this particular area.
Thank you, Ritu, and really appreciate again your time and dialing in late night from the US for this keynote. Appreciate and looking forward that you may be able to attend the future ISA conferences in India in person, hopefully.
Yeah. Thank you so much for having me. I really, really appreciated doing this.
Thank you, Ritu. Bye-bye.
Okay, take care. Bye-bye.